Before this moment, climate science followed a familiar rule. Humans built the models. Humans wrote the equations. Supercomputers followed instructions written decades earlier. Forecasts were slow, expensive, and limited by how much physics could be calculated in time. An AI system named GraphCast, developed by Google DeepMind, stepped into a role no machine had ever held before. And climate science has not been the same since. For most of modern history, predicting the weather meant solving millions of physics equations that describe how air moves, how heat transfers, and how moisture forms clouds. These equations are correct, but they are heavy. They demand enormous computing power. Even today, the world's most advanced weather centers rely on supercomputers that cost hundreds of millions of dollars and still take hours to produce a forecast. By the time results arrive, the atmosphere has already changed. Have you ever wondered why forecasts sometimes feel late rather than wrong? GraphCast approached the problem from a completely different direction. Instead of starting with equations, it started with experience. Decades of global weather data were fed into a learning system. Patterns emerged. Relationships formed that I did not memorize the weather. It learned how the atmosphere behaves by watching how it changed over time. This was not guessing. It was learning structure from reality itself. What happens when a system sees more weather than any human ever could? The difference showed up almost immediately. GraphCast could generate a 10-day global forecast in under a minute once trained. Traditional systems often take hours. That speed alone would have been impressive. When tested against the world's leading physics-based forecast system, GraphCast outperformed it on most major weather variables. Not once, not occasionally, consistently. How does a system trained on data outperform models built on physical law? The answer lies in scale. Human-designed models simplify reality to make equations solvable. They must ignore small details. GraphCast does not need to simplify in the same way. It learns from fine-grained patterns across the entire planet. It sees how distant systems interact. It recognizes signals humans never coded explicitly. The AI does not know physics in the human sense, but it understands behavior. And in prediction, behavior often matters more than explanation. Does prediction need understanding, or is accuracy enough? This shift changed how climate science thinks about authority. For decades, the most trusted forecasts came from institutions with the biggest computers. Now, trust is being earned by models that learn rather than calculate. Meteorologists do not see GraphCast as a replacement for science. They see it as a new layer of intelligence. But that layer is already influencing decisions. Emergency planners, energy operators, disaster response teams all rely on forecasts. When an AI produces results faster and more accurately, what choice do they have? One of the most important impacts of GraphCast is early warning. Extreme weather events are becoming more frequent and more intense. Floods, heat waves, cyclones, every hour matters. GraphCast can spot patterns that signal danger earlier than traditional systems. Earlier warnings mean more time to evacuate, protect infrastructure, and save lives. How many disasters in the past could have unfolded differently with even a few extra hours of notice? Speed also changes access. Traditional forecasting systems are expensive to run. Only a handful of countries can afford them. GraphCast requires far less computing power to generate forecasts. That lowers the barrier to entry. Developing nations that face the highest climate risks could gain access to high-quality forecasting without massive supercomputers. Climate intelligence is no longer reserved for the wealthiest institutions. What happens when forecasting power becomes more evenly distributed across the world? The influence of GraphCast does not stop at daily weather. Climate science depends on understanding long-term patterns. While GraphCast is primarily a weather model, its success has reshaped how scientists think about climate modeling itself. Researchers are now exploring hybrid systems that combine physics-based understanding with AI-driven learning. Instead of choosing between equations and data, the future may use both. Could this be the beginning of a new scientific method? This raises important questions about responsibility. If an AI-driven forecast guides evacuation decisions or energy shutdowns, who is accountable when outcomes go wrong? The model. The engineers, the institutions using it. Climate science has always involved uncertainty. AI does not remove that uncertainty. It shifts where it lives. Instead of uncertainty in equations, there is uncertainty in learned behavior. Are societies ready to manage that shift? Another quiet change is cultural. Climate science has always been cautious, slow, and conservative by design. GraphCast introduced a pace more common in software than science. Rapid iteration, continuous improvement, frequent updates. That speed influences how institutions operate. Research cycles shorten, expectations rise, decisions accelerate. Can traditional climate governance keep up with AI-driven science? Energy systems are already responding. Renewable energy depends on accurate forecasts. Wind, solar, hydropower, GraphCast improves prediction of when and where energy will be available. That helps grids balance supply and demand more efficiently. Less waste, fewer blackouts, lower emissions. The connection between forecasting and sustainability is becoming direct. Is climate action now dependent on algorithmic foresight? There is also the question of trust. Forecasts shape public behavior. When people hear warnings too often, they tune out. When warnings arrive late, they lose faith. GraphCast's improved accuracy has the potential to rebuild trust in forecasting systems. But that trust may shift away from human experts toward machine outputs. When an AI says a storm is coming, will people listen more closely than when a meteorologist says the same thing? Behind all of this is a deeper reality. Climate systems are among the most complex systems humans have ever studied. They involve countless interacting variables across space and time. Human intuition struggles at that scale. AI does not struggle in the same way. It thrives on complexity. GraphCast demonstrated that complexity can be navigated without full comprehension. That is both powerful and unsettling. Should humanity rely on systems that outperform understanding itself? What makes GraphCast different from earlier climate tools is not just performance, it changed expectations. Once accuracy and speed reached this level, going back was no longer acceptable. Researchers, governments, and industries now expect eye-level forecasting. Climate science crossed a psychological threshold. The question is no longer whether AI belongs in climate research. The question is how much authority it should have. In this new reality, humans remain essential. Values, ethics, judgment, machines do not decide what risks are acceptable or whose safety matters. Most, but machines are increasingly shaping the information on which those decisions rest. Climate science may still be guided by human goals, but it is no longer driven solely by human calculation. The center of gravity has shifted. GraphCast did not announce this change with fanfare. It did not arrive with warnings, it simply worked better. And in science, effectiveness has a way of becoming authority. Climate science did not stop being human-led overnight, but a line was crossed. From this point forward, the future of climate understanding will be shared with machines that see patterns humans cannot. Before stepping away, take a moment to think about what was just uncovered. Climate science is changing fast, and understanding these shifts matters more than ever. If this perspective sparked curiosity or raised new questions, support the work behind it. Like the video so it reaches others who need to see it. Subscribe to stay ahead of the next breakthroughs shaping the planet's future. And share this with someone who still thinks climate science is only about equations and forecasts.